Hello everyone. There are new AI video framework allow consumer PC to create long-length AI video based on image2 video generation, and it even work right in your laptop, no supercomputer needed. Today, we're diving into FramePack, a groundbreaking AI framework that's revolutionizing video generation. We are going to see two methods of running FramePack in a local PC, the Gradio UI from the original project itself, and in ComfyUI. First of all, what exactly is FramePack? It's a new AI system developed by researchers Min Zhang and Manish Agrawala, designed to make video generation faster, smarter, and way more accessible. Min Zhang, I think some open-source AI user might saw his GitHub profile before. The author create ControlNet, IC Light, and more. So FramePack, unlike traditional video AI models that hog memory and crash your GPU, FramePack is built to run smoothly on everyday hardware, like your gaming laptop with just 6 gigabytes of VRAM. That's right, you don't need a data center to create 30 frames per second masterpieces. Now here's why FramePack is such a big deal. Most video generation models slow down as videos get longer because they process every frame the same way, eating up more and more resources. FramePack flips that on its head with something called constant length context compression. In simple terms, it squeezes the video data into a fixed size, so no matter how long your video is, the workload stays the same. It's like turning a marathon into a sprint for your computer. Let's talk about what makes FramePack stand out. First, it's super efficient. It can generate videos on consumer GPUs, like an RTX 4090, in just 1.5 to 2.5 seconds per frame. That's fast. Second, it tackles a huge problem in video AI called drifting, where videos start looking wonky over time. FramePack uses a clever trick called bidirectional sampling to keep your videos sharp and coherent, even for long sequences, but there's more. FramePack has this thing called a patchifying kernel. It's like a smart assistant that decides which frames are most important and gives them extra attention, making your videos look better without overloading your system. Plus, it comes with a desktop script that's easy to use. Just download it and you're ready to create. FramePack is proof that you don't need fancy hardware to unlock the future of video creation. It's efficient, powerful, and ready to bring your ideas to life. So we're going to try that out using two installation methods. The first one is going to be very easy. Download the standalone of this project. Click this download link for most Windows users, and you'll have the 7Z compressed file. Once you have that, unzip it and you'll have these 5 files. Basically, the first time you click this runbat file, you'll see something just like what I have here, this Gradio UI popping up. While I was talking, it was downloading all those files. When I started this video recording and clicked that runbat file, it helped prepare all those models and did everything simultaneously. Then, it packages it all together and runs this local URL for you. And then, you'll get started with your Gradio like that. So let's start Gradio first, and next we're going to check out how to run that in ComfyUI. As you can see, the FramePack here has a white color theme. The first time you run Gradio, you can always go down to the settings where you have the display themes. Here, I selected the dark color so it will be easier for us to look at. We are going to drop an image here and add the text prompts. Basically, there are two configuration things that we're going to do. Most likely, we'll change those settings, and then we click Start Generate. It will generate as long as the video length is set here. This is a very important thing we have to check. The length is measured in seconds. So let's say right now, by default, this is set to 5 seconds, and we can go way up to 60 seconds. What it mentions on the GitHub project page demo is 1 minute here, and let's say the maximum is 120, that means it can go up to 2 minutes for generation. But it depends if you have that much time to wait and do that. I still haven't tried that before recording this video, so I'll be trying that right now. Let's try using 30 seconds because most likely I see a lot of people asking in the YouTube comment sections, can we generate videos in one shot for 30 seconds? So let's try this time. We'll set the steps here to 25 steps, distill the CFG scale to 10, and set the GPU inferencing memory to 6, which means 6 gigabytes of VRAM for inferencing. Now, of course, you can set whichever numbers you want. If you want to use more gigabytes of VRAM, you can do that, Or if you're tight on resources, just set it as low as 6 gigabytes of VRAM. And here it mentions in the settings to increase this number if you encounter an out-of-memory error. A larger volume costs slower speed though. So again, it depends on what kind of GPU you have. Just try out different settings. But first, we'll try at 6 and see how that looks. And this checkbox, of course, is for TeaCache if you want to enable that. Is for prototyping. As mentioned on the project page, a lot of people forget that TeaCache helps you render faster. But the generated video results are, you know, sometimes not good or detailed enough because it uses caching and isn't producing high-quality videos. So, if you turn that off, you'll get better quality. If you turn TeaCache on, the result might not look as good. As you can see, this is using the TeaCache generated result, and it doesn't look too good. There's even this weird, scary head twin effect turning around like this. If you turn TeaCache off, you'll get smoother motions like this lady turning around. So there are pros and cons. But TeaCache is mostly for proof of concept prototyping. You want to have a quick way to generate videos, see how they look in a demo, etc. But in real production, I don't think people would use TeaCache to generate videos. So let's try it out. Let's try out an image and see how that looks. I'll put this text prompt. Getting this singer into emotional expressions while she's singing into the microphone. There's some movement and hopefully there are some tears going on her face. Let's see how that looks. So when you click Start Generate, you'll see this action going on. You'll see the operation starting, sampling beginning, etc. Go to the Command Prompts window and you'll see it starting. As you can see right here, we're doing this together. After downloading everything, I go to my URL, unload everything first, and then start our sampling right now. In here, the dynamic swap of Hanyuan Video Transformer 3D models pack is happening, and this is the Hanyuan Video base, which again is the FramePack using Hanyuan Video as the base model to run this. Now it's preserving 6 gigabytes of memory. That means we're only using 6 gigabytes of VRAM in this process. The processing is going on using 25 steps for inferencing. So back to Gradio here. As you can see, the processing is going on pretty fast. On the top here, you see the next latent, all the latent noise in here. You can see it progressing frame by frame. This shows how the process is creating the next step of the video. The next image frames are appearing, and those show us the latent, which isn't fully rendered as the full image like what I'm showing here. But then, you'll see the progress going on. The woman, how that singer is going to perform in the video. So, let's wait for the generated result later, and we'll check how that looks. Okay, so here we have our first generated video, fully using the FramePack Hanyuan video models and generating this 30-second length of video. One shot taken, it's not generated in different batches and stitched together. This is fully, as you can see, 30 seconds of animation based on the first frame of the image, animating her singing and having all different emotional facial expressions and, doing all this in the video. The whole video duration follows what was mentioned in the text prompt about what she's doing. Of course, you can set a longer video length. I'm going to try 15 seconds for another example, and I'm going to try out 16 gigabytes of VRAM here for inferencing and see how that performs in generating this female singer's 30-second video. And it took the frames. As you can see right here, it's 861 frames. Through that, it's using about 2 minutes and 41 seconds to generate each 30 image frames as they're put into the video. So, you can measure that. 1 second of AI-generated video frames takes about 2 minutes here to generate. And that's using the 6 gigabyte VRAM preserved memory size. Therefore, because I have more VRAM to play around with in this scenario, I'm going to try with 16 gigabytes of VRAM and see how that performs. I'll also be using another image. The next one I'm going to do is this image where the woman is riding a bike at high speed on the highway, and it will be animated. What I want to do is create speed motions passing cars in a futuristic urban city. The large language models help me enhance some detailed prompts, which I'll apply in my FramePack UI here. So I'm going to use these settings and see how that looks, generating it in 15 seconds. And we've got the animations generated with this long length of video. How crazy is that? All it takes is just using 16 gigabytes of VRAM, and let's check out the command prompts window because there's something different now. Well, there's some connection loss of the UI connected with Python, I'm not sure. It's just some minor issue happening there. But then, when you see here, each second of the video generated is using 16 gigabytes of VRAM preserved, and then it offloads the Hanyuan video transformer model from CUDA 0, which is my first GPU or graphics card, and then it preserves another 8 gigabytes of VRAM, meaning you release something and stack new stuff back onto the GPU, etc. So it never runs out of memory. Using that stack and queue way, we're running a long-length video. And this way, it's really good. I'm able to generate this long video length this time. One shot, one generation. Only 14 seconds here and we've got this generated video of the girl riding a bike on the highway. It could be like a looping video you can think of. And for the FramePack, I've imagined and thought about what kind of videos are suitable for this FramePack to use. Something like a looping video where you have a long or not very long, like a 30-second or 1-minute video where you have the same position and the main objects keep moving the same way. Or something like an FPV drone view going through bushes, thorns, or something like that, where it never stops with that kind of view. Also, like a car racing scene where you have the first-person view of the driver, the racer driving the car, and you see from their first-person perspective. That's another good scenario for using the FramePack to apply in those video generations. Now, the next thing I'm going to try is a few more examples in the Gradio project here, and then we're going to move to ComfyUI to check out how to install this in ComfyUI. As you can see, the ComfyUI FramePack wrapper is another custom node for AI video, and here's the setup method. As you can see at the bottom of the page, you have the VAE, Vision Clip, and also the text encoder. These are using the repackaged Hanyuan video files where you can use existing Hanyuan video repackaged files published by ComfyUI. In the Hugging Face repositories, there's the Clip Vision text encoder and the VAE that you're going to download. Those files are going to be located in your own ComfyUI models folder in their corresponding subfolders. Save them there. Now for the diffusion model, we're not going to use the Hanyuan video repackaged diffusion model. We're going to have two ways of loading the FramePack model weights. The first one is going to use the official FramePack Hugging Face repository from here. So when you see all these files, they come with separate diffusion PyTorch safe tensor models. There are 3 of these and JSON files for configuration as well. If you've run the previous Gradio UI of this project on the GitHub project page, as I just showed, how to run that using the FramePack Gradio UI, and the simplest way we used is unzipping those files and clicking Run Bat to do that. Once you have this, you've already downloaded the model weights of the FramePack i2v Hanyuan video repository, which are located in your system. So here, as you can see, once you unzip those files and run that frame package, the Gradio UI project, you'll have those run and update batch files as well as the environment batch files. By default, everything looks fine. And if you want to retrieve the downloaded model weights, you can go to the Web UI folder. Underneath the Web UI folder, you'll find the hub folder containing the downloads. From here, as you can see, the FramePack i2v is downloaded here, so you'll need this one. Well, you can reuse this file so you don't have to re-download it for ComfyUI. You've already downloaded the full model weights of the FramePack i2v-HY. Click the snapshot, and in the snapshot, you'll have those configuration JSON files and also the 3 model weight safe tensor files separately downloaded here. So totally 5 files here that you can reuse for your ComfyUI settings. So come back to the ComfyUI GitHub repository, which has the directions here to save that FramePack repository. These 5 files are going to be saved in the ComfyUI models folder under the diffusers folder because the full model weights use diffusers and then the name of the order and the repository's name as the subfolder. So let's create this one and we'll see how that looks in ComfyUI. As you can see, we have 2 file explorers. The one I'm highlighting on the right side, we have ComfyUI right here. Go to the models subfolder, and once you're in the models subfolder, you'll see the diffusers folder here. Click that one and access it. As you can see, I have the previously downloaded stable video diffusion repositories for running mimic motions, and basically, like this instruction file says, put the diffuser's model here. So therefore, we're going to recreate those folder names as mentioned in the instructions. We'll create one folder called the author name, and then we go inside the folder here and create another subfolder called the FramePack i2vhy. Then, this is going to be the location for downloading the model weights for the pack. Because we're using the one we already have running Gradio in my system here, and I've already downloaded it, I can reuse this without duplicating all those files again. Therefore, I can cut and paste all these 5 files into this folder. And there you go, we've got those. Move those files to the ComfyUI diffusers folder, and let's check out if this works or not. We're going to go to ComfyUI Custom Nodes installation. So, for ComfyUI, first we're going to go to the Custom Nodes subfolder, which you're going to access here. Once you're in the Custom Nodes folder, you can start a Git clone of the FramePack wrapper repository of those custom nodes. So, we type git clone and paste the URL of the link of the FramePack wrapper and press enter. You'll see this action going. Once it's finished, we can access this wrapper subfolder. So we type cd and the folder's name of the wrapper subfolder. We go inside here because there's a requirements.txt file. You got to go through that, which is a typical way of running pip install-r requirements.txt. You know, a lot of the new custom node packs require this procedure. Then, once you've finished everything, downloaded successfully, and you've seen all those messages, you've successfully installed it without problems, go back to the folder level, and then you're in ComfyUI. In my case, because I'm using a virtual environment to run ComfyUI, I'll start my command prompt here as usual by using python main.py. Then, once you have this, you'll be getting started with the auto loading. Okay, so back to ComfyUI. As you can see, the workflow right here is a very simple example using the wrapper nodes, and it's included in their examples folder in custom nodes. So you can check that out. The same workflow that I'm using in the wrapper custom nodes examples folder here. Basically, you see the first thing is that we're loading the Hanyuan video VAE using the ComfyUI repackaged VAE, the same files. And then the next thing we're going to check is the dual clip loader, which has the clippy LLAMA3, and the type is set as Hanyuan video, and the conditioning. As you can see right here, we have the positive condition and the negative condition. This is the easier way to use zero-out conditioning, so it's going to be blank as a negative prompt. And the clip vision code, we're using the Hanyuan video image2Video, the same clip vision models. If you've used Hanyuan video image2Video before, you'll have this as well. If not, then come to the Hanyuan video repackaged split files. You go to the clip vision folder, and you can download the files in this clip vision folder. Put that in the corresponding folder in your models folder. The same thing, very easy, simple to go here. The part you're already using for settings is here. I've put my image for this example, resizing the image to make it smaller enough for your GPU to handle. Let's try the base resolution at 512. That's manageable for low VRAM computers as well. And here we've finished all the brief introductions and gone to the sampler. As you can see, the FramePack sampler, this is from the wrapper custom nodes package. You have this custom node for sampling. And this time, I see the author doing better with the wrapper, which has those latent sampler data types in pink dots, and then the conditioning is using the same types as the native node. One different thing is the model only. The models are going to be a different data type. This has its own dedicated FramePack custom node defining the data type for the models here, which isn't the purple dot you usually see in the sampler. Coming to the model loader here, as you can see, there are 2 types of loading methods. The one on the top, which I've just talked about, is downloading the full model weights of the FramePack i2vhy. Here, we have the folder already defined here, so you can scroll back to my previous part if you missed it to see how to put those files in this folder. Or else, we're going to check out another method, which is loading the pack from models. Now, this is the safe tensor files by default, repackaged by KJ and put into his repository, using the FP8 method to trim it down. use this as one of the models capable of loading the FramePack with this file as well. But then I've already downloaded the full model weights of the FramePack i2VHY, so this time I won't be using the safe tensor files that were FP8 repackaged by KJ. If you haven't downloaded the full model weights before running the ComfyUI node, you can easily download one of these two files, FP8 or BF16, whichever works. Put that in your diffusion models folder and run it just like Hanyuan video. So in my situation here, I'll skip this step. I'm going to use my repository that I downloaded from the official FramePack repo and use this package as connected here. As you can see, the same connection data type is showing in green, and then we're going to see what's going on here. Those settings we got, BF16, FP16, and FP32, whichever your computer can handle. Select one of them. So let's try the lowest one, the BF16 quantization. We don't need that, so we disable it. And attention mode, if you have flash attention or stage attention, you can use that. If not, by default in Windows, we're using SDPA, and these are the three options you can choose for your attention mode. So let's say I have sage attention in my PC. I select this one, sage attention, and then go forward here. We've got the compile argument, which is going to be the torch compile settings. If you don't know how to do the settings, just forget it. Leave it alone. You don't need to connect this as a compulsory thing. If you have C installed, Visual Studio, everything installed, then you can connect this to try it out with stay attention and also torch compile together. So let's try it out one time and see how that goes. We're going to animate this image as a video, and then we're coming to the sampler. In the sampler, we have steps, TeaCache, whether you use it or not. In my case, I'm not really a big fan of using TeaCache for my video, so I turn it off. CFG audit setting, I'll keep it by default. One thing you can change for whatever preference you want is the total second length here. This is measured in seconds, and 5.0 represents 5 seconds here. And let's say I want to do 10 seconds this time and see how that works. Running in ComfyUI, the latent video size, which is the size of the latent, how much the AI is going to use for the sampling. As you've seen before, what we did in Gradio UI, you have this next latent, those preview images right here. So, in ComfyUI, it's more flexible. You can set whatever settings you prefer. By default, this is 9, and maybe you can turn it up or down, whichever you prefer. GPU memory preservation has to depend on how many VRAM your GPU has. By default, it's 6 GB of VRAM. This is the minimum requirement that you can run with this AI model. So let's try this first. I'll set this as 16 and see how that looks. If this is like how I do it in the Gradio version, we've seen everything looks pretty much the same in the generated result for video combining, as well as the VAE decode tile. We need this because it's running a very long length of video. Okay, so we've got the generated result here. As you can see, we've spent each second or section here about 2 minutes, and some are 33 minutes on average for each section. For generation, each section spends 30 sampling steps, and then we've got the result, about 10 seconds here. As you can see, the styles are just like what we had in the previous examples using Gradio. Very similar things going on, because we're using the full model weights, running the same files for inferencing, and then ComfyUI is performing the same quality here. So far, the consistency with our reference image here, we have the same character running across the street. There are different motion speeds at different seconds, you'll see here. So it's not going to have blind motions or freezing motions when you're trying to use the previous way, having the last frames of your generated video and then trying to extend the video length with another sampling. The previous method that we tried to do was video extension based on the last video frame of the first batch generated video and then doing the sampling steps again and again, trying to extend the video length. That will sometimes freeze the motion. A simple way to explain it is that it's going to freeze. Let's say to 30 seconds, you'll have a totally different generated result at that moment. So I think this is pretty amazing. It's really a breakthrough for AI video generations running locally in ComfyUI. Whether you use the ComfyUI sampler or the Gradio project interface of the FramePack, you're going to get this kind of extended long-length video using a consumer PC without problems. And then, these examples, I'm trying to do close-up portrait images where I can generate an AI avatar video like this. We can do something that's basically similar styles. The background stays the same, and you have little movement, but you require the video shooting to go over 10 seconds. Then, I think this will be ideally suited for using the FramePack in this kind of situation. And I've tried and laid out the workflow for how that's going to work more conveniently, just inputting all your images and the text prompts here. And then, basically, it will generate the video. I'll try other sampling steps and see if there's any flexibility that allows us to enhance the video. So far, this is pretty cool. We can generate something like a looping video that's over 10 seconds. Very ideal for using the FramePack to make and create something like this. And this is another example that I did, like an AI influencer talking. There's 37 seconds, even this is generated so long here, those mouth-talking motions where it's able to do it. But I see that this model framework kind of creates not really dramatic motions for the video. Even though it's able to handle long videos, you've provided just one text prompt for an entire 30 seconds or even 1 minute video. And, one motion of text prompt instructions won't cover a 1 minute video in reality. So most motions in reality are going to be performed in about 5 to 10 seconds. That's the way emotions behave in real-world situations. So yeah, we'll see how that looks. But definitely this is a breakthrough and advantage for generating a long video length. So I'll see you guys in the next one. Have a nice day. See ya.